Welcome back from spring break, everyone. Today we are just going to jump straight into the lesson. We are starting on section 7.7, and this is on exponential growth and decay. Now, before we get started, I want to make sure that you have a couple of things around you right now. The first thing that you're going to need is a couple pieces of paper or a notebook. The second thing is a pencil. Yes, I am using a pen, but I just want to make sure that you can see it. I want you to be using a pencil. Also, you are going to need a calculator today. You are also going to need your textbook with you, sitting very close by because I'm going to refer to it a couple times. So if you don't have those things, I want you to pause this video, make sure you get paper, pencil, calculator, textbook open to page 464. Pause this video until you have all those things. All right, so we are going to get started. So what is exponential growth and decay? Well, in last section, 7.6, we kind of went over what those graphs looked like a bit. So we're going to talk about that first. So let's review. Exponential function. And make sure you are copying these notes along with me. I'm going to ask you to upload a picture or scan in these notes to me, and that's actually going to be part of your grade now, is just completing these notes with me, okay? So exponential function. So there's two different types of exponential functions that you can have. Either one that looks like this. This we call exponential growth. And then one that looks like this. And this we call, surprise, surprise, exponential decay. Okay, and it's pretty easy to tell just by looking at the graph. You always read a graph like you read a book, left to right. So from left to right, this graph is going up, 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 up. And you can see by this arrow that it's just going to continue going up forever and ever and ever. This one, as you read from left to right, it's going down, 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 down. And it's actually going to go down more and more forever and ever. So that's decay. So the two functions for these graphs look the same. They're both y equals a times b to the x. However, b means something different for both of them. So a is what we call the initial amount. In other words, how much you start with. You start with selling 5 chocolate bars and you increase sales 7% every day, then A is going to be 5, so on and so forth. So that's the initial amount. Same thing with decay. That is the initial amount. Okay, and B, for exponential growth, we call that the growth factor. Now, the thing about B for exponential growth is that the growth factor is always greater than 1. Okay, and for exponential decay, we call this the decay factor. And in this case, it is always between 0 and 1, okay? The growth factor is found growth factor, which is B. Growth factor is found using, what was that? Using 1 plus % increase. So for example, if I said something increases at 7%, then B would be 1 plus 7%. But we never add percents and numbers together, so we would first have to turn that 7 into a decimal by moving the decimal point 2 places to the left. So B equals 1.07. Okay, you see how that works? So if something increases at 7%, you turn 7 into a decimal and you add 1 to the front of it. Okay, that's how you figure out what B is given what the percent is. Okay, over here, the decay factor, which we call B, once again, is found using very similar, but we're doing 1 minus the percent decrease. Okay, so if we knew something was decreasing by 86%, okay, then we could find B by doing 1 minus 86%, or 1 minus 0.86, which is 0.14. Okay, so that is how that works. So these are the two main concepts, and then a specific type of exponential growth is compound interest. So this is the kind of interest that you are going to see in the real world. And interest is basically the bank giving you money for putting your money in the bank. It's a pretty sweet idea. So compound interest is a specific type of exponential growth. Okay, and the formula for that is A equals P parentheses 1 plus R over N to the NT. And every single one of those variables has a unique purpose. So A is the balance. P is the principal, PAL, which is a fancy word for initial deposit. So how much you very first put into the bank. So if grandma gives you $100 for your birthday and you decide to put that all in the bank, then P would be equal to 100 in this instance. R is the annual interest rate. R is usually going to be given to you as a percentage, so you're going to have to turn it into a decimal before you can put it into this formula. N is the number of times interest is collected per year. And then T is time, measured in years. Okay, so let's go back to that grandma gives you $100 example. So suppose grandma gives you $100 for your birthday, right? So we have that P equals 100. That's our principal. That's how much we start with. 1 is always going to stay 1. Now say your bank, say the interest rate is 2% per year. So R equals 2%. Well, we don't want to just put 2% in here because we never mix decimals and numbers, or excuse me, percents and numbers. So we're going to have to turn it into a decimal first, just by moving that decimal 2 places to the left, 0.02. And say this bank collects interest quarterly, or it accrues interest quarterly. Well, quarterly means 4 times per year. So that N is going to be 4. N here and also N here. And then T says after how many years. So say right now you put $100 in the bank. You have all this information in here. We want to see how much money it'll be worth after, I don't know, let's say 10 years. Let's plug in a 10 for T. So after 10 years, you can use this formula and you will figure out how much money, what is the amount, what is the balance you have after 10 years. So let's actually do this. So we got 100 plus parenthesis 1 plus 0.02 divided by 4 to the, we'll just put that in as 40 because we know 4 times 10. And that is 101.22. Wow, you gained a whole $1.22. So, I mean, the more money that you put in to start with, the more money that you will gain. Also, the higher interest rate, the more money you'll gain, but just so you can see how that works. All right, so now what we're gonna do is a couple problem examples. So this is it for your notes. I'm actually going to do an example from every bit of the practice problems that I'm going to give you so that you can know for sure how those are done. So open your textbook to page 464. Make sure I'm still in the frame. Okay. Page 464. And I am going to do number 10. This problem is not assigned to you, but I just want to show you how you will do number 9 and 11. So it says identify the initial amount and the growth factor in each exponential function. So we're given the function is y equals 150 times 1.0894 to the x. So it's asking us to figure out the initial amount, A, and the growth factor, B. Well, we know the formula is y equals A times B to the x. So the initial amount is 150. And the growth factor, growth factor is 1.0894. Okay, it's that simple. You just look at the number attached to the x as the exponent, that's your growth factor, and the starting amount is the number that is not attached to the exponent, the a. If it were to have asked for what is the percent increase, that's where we would say, okay, the percent increase is so to find the percent increase, we look at B. And we know B is 1+% increase. So we found that B is 1.0894. Okay, so to find the percent increase, we just solve for it, subtract 1 on both sides. So 0.0894 is equal to the percent increase. Okay, and if you wanted to express that actually as a percent, move the decimal 2 places to the right, and you would get that 8.94% increase. Okay. All right. Let's look at number 14 now. Number 14. Actually, you know what? I'm gonna have you pause the video right now, try numbers 9 and 11, and I'm gonna write the answers for you. I want you to show the work on your paper, but I'm gonna write the answers for you for number 9 and 11 right now. So go ahead and start those, pause this video, and then once you turn it back on, you'll see the answers. Why don't you try number 13 as well? Pause the video, try 13, and then come back to it. Now I want to tell you right now, if this is all that you're writing, you are not going to get full credit for this. I have got to see the work, I've got to see the formulas, I've got to see the steps to make sure that you are actually trying this on your own. Okay, let's do number 14 together now. So number 14 says a population of 100 frogs increases at an annual rate of 22%. How many frogs will there be in 5 years? Write an expression to represent the equivalent monthly population increase rate. Okay. So this is percent increase. So 100 is your starting amount. You know that they increase at an annual rate of 22%. However, 22 is not B. B is 1 plus the percent increase. So B is actually 1.22 decimal right there. 1.22 is B. Write an expression to represent. How many frogs will there be in 5 years? So y equals a times b to the x. Y equals 100 times 1.22 to the x. But we know that x is 5. Put that in your calculator. So there will be 270. Okay, the last one I wanted to do with you is number 16. And number 16 is using our compound interest formula that we just talked about. So that is A equals 1 plus P times, oops, here I have that mixed up. No, sorry, scratch that. A equals P times 1 plus R over N to the NT. All right, so all you have to do is figure out what all the variables are, plug it in, put it in your calculator, and you're good. So it is asking for the amount, the balance, after a $12,000 principal earning 4.8% compounded annually after 7 years. So the principal is $12,000. Then you have 1 plus the rate is 0.048. Remember to write that as a decimal, not as a percent. Do not ever put percents in your formulas. Over N, so N is the number of times compounded per year. So it's saying compounded annually. That means 1 time per year. N again is 1 times T. It asks after 7 years. So 1 times 7. Okay, so into the calculator that goes. 1 plus, we'll just simplify this a little bit, 0.048 to the 7. So after 7 years, you will get $16,661.35. Okay. Power School now has the rest of the practice problems that you are to try. I'm going to continue writing. I'm just going to put the answers on here. So go ahead and play this video or pause this video right now. Try the problems on Power School and then look back on here and the answers will be on here. Once again, if you just have the answers written, you will not receive full credit. You have to make sure that you have the work for it as well. So pause, you should be paused now, and then come back and you can check your work with the answers. Okay guys, give this video a thumbs up, like, subscribe, you know what to do, and I'll catch you next time.